Hi everyone. Today I'm going to discuss about the modular arithmetic. So before going to the concept of modular arithmetic, we will discuss the number system, the basic number system. As we know, the number system n denotes the natural number. Natural number is a set of all numbers, includes 1, 2, 3, etc. These are the numbers, that is all positive numbers. We called it as natural number. And in this chapter, we mainly concentrate on the number system that is that is we called it as integer. Integer is a set of all numbers begin from 0 and all positive and the negative numbers, that is plus or minus 1, plus or minus 2, plus or minus 3, etc. So actually we have the different sets of numbers: whole number, integer, rational number, irrational number, real number, as well as complex number. Okay, so now we will concentrate on the integers. Integers means in this chapter, if I take the two numbers, say a and b, so a and b, mainly it is an integer. So either integer, nothing but just you can concentrate these numbers: 0 or positive numbers as well as negative numbers. Now we'll go to the concept that is divisibility. So divisibility. So this is just a basic definition of the division. So this we will denote like this. If I take a two numbers, say a and b, a divides b. So I will denote like this: a divides b. That is, if I divide the number b by a, so we will get a remainder is 0. So you multiply any number, say q, and this become q into a, and the remainder becomes 0. Then we say that a divides b. Example: 2 divides 6. 2 divides 6. For example, if I divide 6 by 2, so 2 3s are 6, and the remainder become 0. Similarly, 2 divides 12, 3 divides 9, and so on. Okay, so this is the divisibility definition. So just two numbers divides one number divides another numbers, so we will denote in this symbol a divides b. We called it as a divides b. Now coming to the next topic is division algorithm. Division algorithm. Okay, now consider the two numbers. So that is a, I am dividing a b by a. So just I will multiply here, say q, with this become q into a, and we will get the remainder r. So this is a usual process, that is middle school level. We learn the division in this way. So this here q is called it as a quotient, and r we called it as a remainder. So in this case, b, this implies b can be written as q into a, q into a plus r. Or in another way, if I say r can be written as b minus qa. So example, if I take, for example, 5 divides 21. If I divide 21 by 5, then 5 fours are 20. So then the remainder is 1. So according to this above definition, so generalize, so I can write b, that is 21. 21 can be written as 4 times, that is q into a, that is 4 into 5 plus 1, or in another way, 1 can be written as 21 minus, that is b minus 21 minus 4 into 5, that is 20. So this is one example. Similarly, if I take another example, so if 3 divides 28, so 3 and 28, if you divide 28 by 3, so you'll get 3 nines are 3 nines are 27. So then we will get the remainder is again 1. So again in this way, if I write in a generalized way, that is 28 can be written as 3 into 9 or 9 into 3, 9 into 3 plus 1, or 1 can be written as 28 minus 9 3 is a 27. So and so on. Now we'll discuss the concept greatest common divisor, that is GCD, or highest common factor HCF of two integers, say A and B. So the greatest common divisors of two numbers A and B is denoted in this way, that is open bracket A and B and is equal to D. For example, say D is a common number, a number which divides A and B, and D is the greatest. So how we can say D is the greatest common divisor, or how we will calculate A and B? For A and B, D is the GCD. So it satisfies two conditions. The first one, D divides A and D divides B. So D is a common number which divides both A and B. Second one, if any other number which divides A and B, for example, say X divides A and X divides B, X divides A as well as X divides B, then this implies X divides D. So this is the conditions we say that D is a common divisor or greatest common divisor GCD. Example we will discuss. So for example, GCD of 12 and 18. So in a different way we will calculate the GCD. So one easiest method, go on divide this 12 so and 18. So 18 and 12 we will divide. So 12 ones are 12 and the remainder is 6. So now divide 6 and 12 again. So 6 and 12 again. So 6 twos are 12 and the remainder is 0. So in this process if you continue until the remainder becomes 0, then the last non-negative remainder, we called it as GCD. That is GCD of 12 and 18 is equal to 6. So this is the way we can calculate greatest common divisor in one method. We have a different method, and on the basis of this we have an algorithm, we called it as Euclidean algorithm. Two numbers we say relatively prime if the GCD of A and B is equal to 1. Okay, so that is example, if I take GCD of 3 comma 5 is equal to 1, GCD of 4 comma 9 is equal to 1. So nothing but if the GCD of two numbers is 1, then we say that the numbers are relatively prime. Now in the next session we will discuss about congruence modulo n.